So here's a good way to do this sort of rough concept prototype utilizing a piston inside of a given air volume in a resonating acoustic Stirling engine effect manner. Okay, so we're going to take air in one side and standard valves. So if you think in any way we can't redirect kinetic, we already have valves. They spin a chain, they take a certain degree of kinetic captured to go the same direction of spin as the crankshaft and produce a given greater effect of power capture from our engines. So first and foremost, you're already wrong. It can definitely be done. Simplistic, easy concept. Crankshaft spins, gear spins, crankshaft is tied to camshaft timing, and camshaft opens up valve and closes valves correctly at the right time to continue the effect of kinetic thermal energy captured, which is pressure more than anything. Okay. Now, we're going to go back to the cylinder. One singular cylinder. That's all we're looking for. Now, it will have to slow down that pressurized fluid of air that's there on the other side, of course. It has to then stall the air in front of it. It then needs to be electrically excited in a polarized manner, kind of like, give it a second, magnetic and electrostatic alignment. Utilizing the kinetic that's now thermally there in the cylinder, allowing for the right resonance passively because of the air getting blown out in front to a degree or off the sides to a degree. With the heatsink fins here on the sides, in alignment with the air traveling, it would then pump and resonate and accelerate the air it stalled and started its degree of continued directionality and accelerated it on the outside of the cylinder. The reason why we wouldn't do it that way as a rough prototype is because it's shit. It's really stupidly shit. It is a really dumb way of doing it. It can be done. It's inefficient as hell. And why would you do it that way when you could just do it better? A better way to do it is take a look at the most simplistic linear accelerator of all. A coil gun in a rail. Repulsor technology. So, in this instance, we'll have eddy currents and a permanent magnet and a coil gun. At the very end, there is a, of course, coil of aluminum. Now, as we accelerate with, of course, air in the cylinder that we need to have it ultimately bounce off of, taking that air out as it moves that direction is all that's necessary. Putting it into a more captured, energetic state, ready to be reintroduced onto the eddy current, meaning slowed down permanent magnet at the one end that you want it to travel to, will then recapture that first initial forward thrust, and then the air, of course, that was removed and moved is then reintroduced in a higher kinetic capacity, thermoacoustic capacity, thus gaining a opposite reaction of travel that we can then capture as it moves the other direction. In this instance, it would have to be work motion is what we're looking for, And so you'd probably end up with a series of captured, simplistic electricity to an electric motor design. The linear accelerator first accelerates, is heated up because it's compressed. It then captures a degree of its extra heat thanks to a resonance thermoacoustic pump along the outside. You know, kind of like an AC compressor. It phase changed, of course. Hopefully it's a liquid now and absorbs some of that energy. We're then going to impart it in the direction of travel, and then we gain back some degree of that energy loss through the increased degree of exothermic captured, and depending on the scale and all the rest of it, you might be able to get more than what you put in for the given design. This is a rough prototype. All we're talking about is the Stirling solenoid engine that takes a degree of the heat around us and puts it back in. Well, there's electrical resistance. And so, regardless of whether or not it's copper or aluminum, it should still capture some of that extra heat and try and recapture some of that energy used. And if we can figure out a way to have the bike, or whatever it is that it's trying to move forward, slide much more easily forward during that reverse direction of travel with the magnet, we will now have a gained degree of increased thrust. Even though we're making some electrons along the way, that initial impact moving forward was captured, and then it, in its relative perspective, stands still while the rest of the body of whatever it is that's moving moves forward, and it resets it up like a semi-automatic gun. And it goes bang again, and then we recapture it again. It goes bang again and recaptures again, and faster and faster. And the more of these that you can possibly add into a given tube system, the more efficient at removing heat and transferring it to kinetic it becomes. The more air that rushes over the heat sinks, the more heat used and recaptured for electricity gained. And now you have the basic rough concept prototype of the kinetic linear accelerator that this would be. As a result, it's rather simplistic to make it. You only need a pretty simplistic, again, style of radiator. One that increases the likelihood of capture during phase change, reduction of resistance, of flow, of travel of air, and the correct resonating frequencies, so there are always enough pushes forward occurring inside of the cylinder to overcome the loss associated at first, and then an amplificatory effect once enough degree of momentum and inertia has occurred, gaining you a net positive. If only we could figure out a way to accelerate it faster using this. You see, faster the speed, the greater the inertia, the greater degree of efficiency, meaning the faster the acceleration, the more efficient you get for the given mass involved. Lower mass, faster acceleration, more of them accelerating, better resonance there within, capture of energy from heat to kinetic directionality, and recapture of energy used during initial acceleration the better and better it comes down to being able to efficiently move in the direction of travel desired. And now you have the reasons why it works in a much more simplistic, easier to understand, much more believable way of going about making it happen. Because you see a wave of inertia that propagates forward during that travel, and a much more reduced frictional component moving the opposite direction allows for a continuation of acceleration that is far more captured, far more able to overcome certain resistances, i.e. frictions. It's a pump that's done very, very, very well. That's all it is. It's a simple pump that resonates more one direction of travel for its given amount of energy than the other. All I said was, oh, well, I can just put an electric motor on that. And so I reduced the amount of resistance of travel desired versus the other. Just like stated before with my previous video. So, how about them apples? Think you can understand it a little bit better now? Believe me a little bit more as to why this could happen? Or are you just going to say it can't be done and you're a crackpot? Have fun.